Welcome to The Explainer. Today, we're unpacking some truly mind-bending material from a fascinating presentation called Physics to God. We're going to be exploring the absolute bleeding edge of fundamental physics. We'll dig into the deepest mysteries of the universe and look at the perfectly tuned numbers that literally make reality possible. The source material takes us on a wild journey, going from the absolute smallest building blocks of existence all the way up to the biggest, most provocative questions that scientists and philosophers are asking right now. It's an absolutely fantastic exploration, and we're going to break the whole thing down for you today. Let's dive in.
So here's our roadmap for the journey. We're going to cover the bottom of science, the universe's Legos, the constants of nature, a theory of everything, and finally, the ultimate unsolved mystery.
All right, part one, the bottom of science. Let's zoom in on reality.
To really understand the universe, physicists tell us we basically have to keep zooming in. Think about it. When we look at living things, plants, animals, ourselves, we're studying biology. But if you look closer at those organisms, you quickly realize they're made up of cells, and those cells are made of molecules. So suddenly, biology just reduces to chemistry. Well, where do those molecules and atoms actually come from? They reduce down to physics. And finally, at the very, very bottom of that chain, deep inside the atoms themselves, we find fundamental particles, things like electrons and quarks. These are the absolute base units of our entire existence.
Now, the crucial thing to remember here is this definition: fundamental physics. The word fundamental is absolutely key for us today. It means something that is completely irreducible. You literally cannot break it down or explain it in terms of anything else. When you strip away all the crazy complexity of stars and planets and us human beings, you are left with these fundamental particles. They are the absolute bottom layer of our reality. Moving right along to part two, the universe as Legos. Okay, so wrapping your head around abstract quantum particles can definitely be tough, but the source material gives us a brilliant analogy. Picture a sprawling, incredibly complex Lego city. We're talking towering skyscrapers, massive bridges, little cars, the whole shebang. It looks unbelievably complicated, right? But when you look closely, that entire city is actually just made up of simple, basic Lego blocks. Different colors and sizes, sure, but they're just simple blocks. The source explains that our universe is exactly like that city, just on a much, much grander scale. All the immense richness of the cosmos, from a burning star to you and me, is ultimately just different combinations of incredibly simple fundamental particles, like those electrons and quarks. But a bunch of fundamental particles just floating around doesn't magically give you a universe. You need rules for how they interact. Physicists have discovered two overarching scientific rule books for this. First, we have quantum mechanics. This governs the microscopic world and dictates exactly how these particles interact with one another. And second, we have general relativity. That's Einstein's masterpiece, setting up the macro framework, the actual fabric of space and time itself, where everything exists. To really anchor this, let's bring it right back to our Lego city. Quantum mechanics is like the specific rules of the Lego pieces themselves. It's how the little bumps on a yellow piece snap perfectly into the grooves of a blue piece, or why certain pieces just will not fit together no matter how hard you push them. General relativity, on the other hand, is like the table you're building your Lego city on. Is the table flat? Is it curved? Does it have hills? General relativity provides the spatial geometry where all that snapping together actually happens. Let's jump into part three, the constants of nature. It's time to look at the exact numbers. So, beyond the particles and those big overarching rules, there are exact, unyielding numerical properties baked right into the universe. Now, to understand why these constants are a real game changer, we have to look at the difference between a qualitative property and a quantitative property. Qualitatively, you might know that an electron has mass, meaning, if you put it on a tiny scale, it weighs something. That's a quality. But quantitatively, you're asking exactly how much does it weigh? What is the specific, completely unchangeable mathematical number attached to that mass? Just look at the sheer absurdity of this number for a second. This massive, insanely precise decimal is the measured mass of an electron in kilograms. It's an unbelievably tiny but wildly precise value. But here's the mind-blowing part. It isn't just the number itself. It's the fact that every single electron in the entire universe weighs this exact same amount. No exceptions. It never varies. It is mathematically locked in. And that, my friends, is why it's called a constant of nature. And here is another incredibly precise constant highlighted by the source,
the fine structure constant. While mass tells us how heavy an electron is, the fine structure constant quantifies an electron's charge. Specifically, it dictates the exact strength of the electromagnetic force between electrons. Notice the extreme precision again, always exactly 137.035999139. That number dictates how particles repel or attract each other everywhere in the cosmos. So, how does this map back to our legas? Well, the mass of an electron is just like knowing the exact fractional weight of a single red Lego brick in grams. And that highly specific fine structure constant? Think of that as the stickiness of the Lego bricks. You know how some Lego pieces pull apart super easily, but others require you to practically break a fingernail to get them separated? The fine structure constant measures that exact strength of interaction between the foundational pieces of our universe. All right, part 4. A theory of everything, the absolute holy grail of physics. Knowing all these different pieces, the overarching rules, and these highly specific numbers, the ultimate dream of physicists is to wrap them all up into one neat, unified package. The historical drive to pull this off is perfectly captured by Albert Einstein, who said, "In the whole history of science, from Greek philosophy to modern physics, there have been constant attempts to reduce the apparent complexity of natural phenomena to some simple fundamental idea. And relationships. This is the underlying principle of all natural philosophy." Basically, since the dawn of science, the entire goal has always been simplification, taking the dizzying, chaotic complexity of the world and reducing it down to simple, foundational truths. Think back to long ago. People looked at an apple falling straight down from a tree to the ground. And then they looked up at the moon, orbiting in a massive, continuous circle in the sky. To the ancients, these seemed like completely different phenomena governed by totally different rules. But then Isaac Newton comes along and proved that both the falling apple and the orbiting moon are actually doing the exact same thing, governed by one single, elegant rule, the law of gravity. He basically unified the heavens and the earth under one brilliant mathematical concept. The source material offers a really fantastic analogy to explain this intense drive for unification. Imagine you have a complex moral code with dozens of distinct rules. You know, don't steal, give 10% to charity, don't slander your neighbor, don't overcharge for goods. It's a huge, complex list to remember. But then you realize you can unify every single one of those diverse rules under one foundational principle, the golden rule. Treat your neighbor as you would like to be treated yourself. Suddenly, all those complex rules are just natural expressions of one incredibly simple, elegant law. And that brings us to the holy grail of modern science. The ultimate goal of physics is essentially searching for its own golden rule. They call it the theory of everything. It's a final, fully unified theory from which all particles, all the laws, and literally all the complexity of the entire universe can be seamlessly explained in one go. Which leads us to part 5. The ultimate unsolved mystery, the final hurdles. Now, despite some massive leaps forward in science, this theory of everything currently remains just out of reach. According to the source material, there are basically 2 major final bosses standing in the way of physicists claiming victory here. First up, scientists have completely failed to unify quantum mechanics with general relativity. The rules of how our little Lego pieces snap together simply do not play nicely with the rules of the table they sit on. But the second hurdle is even more baffling: the constants of nature. Physicists currently have absolutely no underlying theory to explain why the mass of an electron or the fine structure constant are the exact, absurdly precise numbers that they are. They just are. And this brings us right to the core argument presented in the source material. The physics to God presentation argues that this unexplained exactness is not just a math problem, but a profound philosophical clue. The argument is that because these constants are so incredibly precise and so fundamentally essential for the universe to even exist, their inexplicable nature presents a major challenge to finding a purely physical theory of everything. Instead, the source argues, it points directly to an intelligent cause or creator. Which leaves us with a truly profound question to ponder as we wrap up today. Are these perfectly tuned, completely unexplained numbers the fingerprint of an intelligent designer who set the exact parameters of reality? Or are they simply a gap in our current scientific knowledge, just waiting for the next Isaac Newton or Albert Einstein to come along and provide the physics breakthrough of the century? It's a completely fascinating debate that bridges the very bottom of science with the highest philosophical questions we can possibly ask. Thank you so much for joining me on this explainer, and I hope this leaves you with a whole lot to think about.